Yes, 5.7. All right, so what we're going to talk about today is the graphs of our ratio trig functions. So our tangent, our secant, our cosecant, and our cotangent. Okay. Most of this is going to be simply done on the calculator. I am going to show you how we get our reciprocal trig functions from our basic trig functions. So we're going to be doing a lot of back and forth. So you should have that cosine curve out in front of you. That's not the right one. That we did a while back. This isn't the right one. Okay. Yeah, it was at basically towards the beginning of the unit, right? Okay, so the four trig functions we saw in the last lesson are sometimes known as trig ratios because they can be written as a ratio. Like secant can be written as what? 1 over cosine. Yeah, secant's 1 over cosine. What is cosecant? 1 over sine. What is cotangent? Or? Oh, give that back to me. It's not sine over cosine. All right, you can have it back, I guess. All right. Did I go over all of them? I did. What's tangent? Oh my God. All right. So first we're going to talk about, y equals secant, okay? Secant of x. So secant goes with what reciprocal trig function? What's its reciprocal? Secant is cosine, okay? So we're going to take a look at our cosine curve that we graphed a while back, and we're going to learn how to get the secant function from the cosine function, okay? Okay, so here's our cosine curve, right? Yes? Okay. Now, we said that secant was the same thing as 1 over cosine, agreed? So let's think about what would happen, or what happens when cosine equals 0. Yeah, we have issues, right? If cosine equals 0, we have issues. Why? It becomes undefined. Okay, so on your cosine curves, I want you to take your colored pencil, and I want you to circle every place on that graph where cosine is equal to 0. How many places should you have? 2. Okay, so I want you to circle them for me. Okay, so we know that secant's going to be undefined here, right? What happens graphically when a function is undefined? What happens? Yeah, awesome. Okay. Graphically, when a function is undefined, we get these asymptotes. In this case, we're talking about a vertical asymptote. So with that same colored pencil, I would like you to put a dotted line, and I need to do it in another color because I already have dotted lines here. I'd like you to put a dotted line, vertical dotted line, to represent those asymptotes. Okay. So you're going to have a dotted line, whoops, at 90 and 270. Okay, those are going to be your asymptotes. So can secant exist there? No, absolutely not. Okay, so what we're going to do next is we're going to remember, or maybe look at the table in our notebook that we created, and you're going to tell me what secant at 0 is equal to. You have that little table in your notebook. Pull it out. What is secant at 0? Think about what cosine at 0 is. So what's secant at 0 going to be? Good. It's going to be 1. Okay. So I want you to put a point at 0, 1. The colored pencil color. All right. What's cosine at 180? Negative 1. So what's secant going to be at 180? Negative 1. So I want you to put a point at 180, negative 1. All right, so what's secant going to be at 360? 1 again. Okay? So what winds up happening is my secant curve intersects my cosine curve at its maximums and its minimums. Okay? With those asymptotes being where the function is equal to 0. So go ahead and enter a graph page. And I want you to graph secant x. Now, can we use secant? How do we have to type it in? 1 over cosine. Very good. Okay? Because those reciprocal trig functions are not going to be available to us. Why did it come out ugly? What should I do? What should I do? Why did it come out ugly? It should be curvy, right? Why is it ugly? What do I do? How can I change it? Think about what we did yesterday when we were graphing on the calculator. No? Nope. Give you a hint. It's in the menu. We did. Yeah, we did. Yeah, we definitely did. We had to, because then we wouldn't have been able to graph anything on our calculator and trig if we hadn't. We have done this. Okay. You're right. We have never, ever done this. Continue. What do I do next? Thank you. Because this adjusts it to what window? Which is what in radians? Negative 2 pi to 2 pi. Okay. So here's the window on our paper, right? Here's our cosine curve. Okay. So what does secant look like? Where it touches its maximum, right? It goes up. Where are our asymptotes here? Okay, where it crosses through 0 on this axis. Here's our asymptotes. This is your secant curve. So I want you to sketch this in using your colored pencil on your paper. You already have the red curve. You already have cosine. You're going to sketch in the blue, which is secant. Doesn't touch what thing? The asymptote? No, it never ever touches the asymptote. It gets arbitrarily closer. It gets closer and closer and closer and closer and closer, but never actually touches it. You don't need this. Nope, only where the cosine curve crosses through the x-axis. Make sure you label it. All right, so there's your secant curve. Not bad, right? Okay, so what happens when we have 0 for cosine? We have asymptotes. Okay, so that's 1.5. We have asymptotes at those values of x. We graphed it using our calculator. There you go. Maybe. Okay, so which of the following represents the period for y equals secant x? Now, all of the rules that applied for our basic trig functions, sine, cosine, and tangent, are going to apply for our reciprocal trig functions. Okay, so how do I find the period? Two pi over b. What's b represent? Frequency. What's the frequency? 1. Frequency can be found in front of that x, right? Nothing's there, it's a 1. So what's my period? Yeah. Okay. Okay, 2 pi. So again, all of those same rules apply. Amplitude, frequency, period, all of the same stuff, okay? All right, which of the following could not be a value of secant? Nope, we can have 3 over 2. We can have 5 over 4. We can have 1. We can't have a half. Why? Can't have a half. Why? Here's my graph, right? What did my function start at? 1. What did it start at? Here. -1. Does it exist between 1 and -1? No. Okay? So our reciprocal trig functions for sine and cosine or secant and cosecant aren't going to exist between 1 and -1. Okay? Okay, we already talked about tangent, so we're going to kind of skip over this piece and we're going to talk about cosecant. Okay, so here's our sine curve. Tell me where I'm going to find my vertical asymptotes. 0 pi and 2 pi. Good, so go ahead and put your vertical dashed lines in there. In a different color than you drew the actual curve in, please. And I know my lines aren't straight. I apologize. Not even close to being straight. We can pretend. Okay, so this is going to follow the same trend as secant. So what are we going to see happen at pi over 2? What is cosecant going to be? At pi over 2? What's cosecant going to be at pi over 2? It's going to be 1, right. And where's it going to go from here? Yeah, it's going to kind of look like this, right? And what's going to happen at 3 pi over 2? Yeah, it's going to start at -1 and it's going to go where? Down. Okay. So there's your cosecant. You okay with that? All right, good. All right, I want to look at this last problem here on the calculator. At how many values of x on the interval between 0 and pi is tangent equal to cosine? How could I do this? Easily. Nope. Nope. I want to know where tangent is equal to cosine. I could graph it. Yeah, absolutely. Okay, so we're going to graph tangent. We're going to graph cosine. Okay, everybody should be doing this. So add a graph page. I want you to graph tangent and graph cosine. What's wrong with this picture? Yeah, so I need to hit what? Menu. Window. Zoom trig. All right, so this gave it to me on an interval from -2 pi to 2 pi. What is the question asking? On what interval? What interval is it concerned about? 0 to pi. Okay, so I need to adjust what on here? What do I need to adjust? What numbers? -360 needs to change to what? 0. 360 needs to change to what? 180. Very good. So my suggestion is if you can't get it to click, double click on the Y maximum because that will allow you to get into it very easily. Okay? So how many places are they equal to one another? 2. Where are you finding that they're equal? How do you know where they're equal? Yeah, they're points of intersection, right? So there's two places in which cosine and tangent are equal to one another, between 0 and 180. Okay? All right. Were there any questions from the midterm review? 0 to 180.